Okay, welcome everyone. This is the week 8 webinar. And so we're getting pretty far into the class and there's a lot to talk about, but let me share my screen so you can see. So the plan today is I'll answer any questions you have as always. I'm always happy to answer questions. One of the big points of these webinars is so that you can ask questions and I answer right away instead of having to wait until, I get back to you on a Q&A or email or something. And I can answer questions. And then we're continuing the same idea that we did last week, but instead of doing a hypothesis test to see if, say, a mean is bigger than 0.4, instead we're going to be comparing two different things. So the first little piece we're going to do is we're going to do a hypothesis test and a confidence interval for the difference between two proportions. So if you have two proportions and you want to see how different are they, or are they different, or is one bigger than the other, then we can do that, or we will be able to do that after today's webinar. Then we'll get into a hypothesis test and a confidence interval for a difference between two means when they're independent of each other. So I'll talk about what does independent mean in terms of, deciding what type you've got, but we'll look at means. Then we'll talk about a hypothesis test and confidence interval for the difference between two means when they're dependent. So we'll talk about that also. And then finally, last week we talked about project 2, but now we're ready to really talk about all of the details because project 2 is really all about this week. So it's about this week's material. And that is the plan. And I just want to remind you, we're in week 8. 8 is an even number. So what does that tell you you're going to have to do this week? Yeah, it means there's an exam. Every even week, there's an exam. And hopefully you're getting used to what the exams are like. So like around half of it is older stuff. And then the other half is the new stuff. And then the last couple questions are, typed out questions instead of like multiple choices or type in a number. But, you have to really write the full sentences. So that's this week. Make sure you're ready for it. And again, you don't want to get there. You don't want to do it until you're done with the rest of this week's assignments. And that includes the discussion board reply. And it also includes the chapter 10 assignment. So make sure you do that first and then you'll be ready. So that is the plan for today. Are there any questions? While you're thinking, or you can type it out or saying it. Just a note, if it's really important that you do your discussion post assignments, make sure that you get that set up, your initial post by Thursday. And don't wait until Sunday late night to do your reply because there may not be anything good left. And then you're stuck trying to reply to something that's useless. So again, strongly recommend don't wait until the last minute. All right, because it's much easier and there's better stuff to reply to if you're not waiting until Sunday night. Just a very strong suggestion. I noticed some of you were stressed out on Sunday night because like there's nothing good. And it's like, well, don't wait till Sunday night. And then there will be something good. I want to mention one more thing, and that is on Friday, I will not have my office hours. Anyone know why? Did I see the reason why Friday don't have office hours? Here's a hint. If you come to the college and go to my office, you'll be sent to jail. Yeah, Veterans Day. So it's a holiday. The college is closed. I'm not allowed to work. I can answer emails, but I'm not supposed to have anything official. So Friday is a Veterans Day. We're supposed to, I think it's a good thing that we're honoring our veterans. And so I won't have office hours on Friday, but I do have office hours Tuesday, Wednesday, and Thursday, like always. And I will be checking the discussion boards and, the Q&A forum, and also check my email. So, please, ask questions if you have them. Any questions? Any questions? Okay, if there's no questions, I think I'm going to talk about an application. And let me ask you something. What's the big thing happening tomorrow? I guess, as you all know. Yeah, it's election day. So I figured I'd do an example of an election. So here we go. So is there a difference between Democrats and Republicans in enthusiasm for voting? Okay, so the idea is, if you ask a bunch of Democrats and you ask a bunch of Republicans, are you enthusiastic about, voting tomorrow? Okay, or if you're like me, I voted last week. Then is there a difference? What do you think? Do you think there's a difference between Democrats and Republicans in enthusiasm? Or do you think they're just the same? Anyone, any thoughts? I see y'all jumping in. Okay, you don't want to jump in? Okay, so the question is there a difference? So with this question, this is a hypothesis test thing. Okay, so we got one yes. Okay, if we think there's a difference, then what we're going to do is we're going to conduct a hypothesis test to find out if there's a difference. Does that make sense? So we're going to use the same step-by-step process for hypothesis testing that we used last week when we had a single group or a single sample. But now for this example, there's going to be two groups. We have the Democrats and Republicans, and we want to compare the two. And I just want to let you know, I would say of all hypothesis tests that happen, this week's are the most common, where you're comparing two different things, seeing if one's more than the other, or one's, if they're different from each other, one's less than the other. That comes up all the time. So very easy to come up with how these things work. So the idea here is we go through the same process in hypothesis testing. So the first step after wondering, what you think, is to write down the null hypothesis and the alternative hypothesis. Okay, the difference now is last week when we looked at the null hypothesis, it was always mu equals some number or p equals a number. But now what we're doing is we're comparing Democrats to Republicans. We don't know either of them. So here we want to find out if the proportion of Democrats who are enthused about the election is the same as the proportion of Republicans who have enthusiasm for the election. Any question on that? And notice it's a proportion, because the survey question would be, are you enthusiastic about the election? And the answer would be yes, or maybe no, but not 73. Okay, it's a yes, no question. Any questions so far? Okay, so once we have that, then we're going to go here. And we need to type what our H naught is. Any questions so far? I think I need to go to insert equation and then don't insert one. but then go here. And now I can do it. There we go. So here's our mu. It's sorry, it's our not mu, our p, because we're talking about a proportion. And it's a proportion of Democrats. So I'm going to go P sub D. The proportion of Democrats who are enthused, is that equal to the proportion of Republicans who are enthused? Any questions on H naught? Okay, let's go to H1. If we want again, we're saying, is there a difference between Democrats and Republicans in enthusiasm for voting? So H1 is going to be P sub D. And then what inequality am I going to put for the H1? So what's next? It's very important that you're going to be able to do this too. Okay, you could say more than, except difference. If the Democrats are much less than the Republicans, that's still different, right? So more than's not enough, because if Democrats are much less, that's also would be a part of H1. So instead, what is it? I don't see y'all jumping in. It's not more than, and it's not less than either, because then more than would matter. This is a two-tailed test. When you have a two-tailed test, it's a not equal to. Okay, so H1 is they're not the same. Different from is the same as not equal. And that's P sub R. Any questions so far? Okay, notice a type 1 error would mean that we rejected H naught, we accepted that they're different, but they're no different. So what would happen is we would, if we were a news place, we would publish an article about how Democrats really differ from Republicans, and we're wrong. That'd be bad, right? Okay, on the other hand, a type 2 error, let's see, why would it be that again? Why would it be the not equal to sign, or why would it the not equal to sign? Because the key word here is difference. So not equal to means different, right, from each other. Is that clear? Yeah, so good question, because it's very important that you get these right, or it'll go poorly for you on the exam. Okay, so a type 2 error, in that case, you would not be able to reject H naught, and you're not able to say they're different. You're not going to say they're the same either. You never accept H naught, but basically you're going to not say anything. You're not going to be able to publish an article, but your idea was right. They were different, but you don't publish because you don't have any evidence for it. And if you're a news company and you don't have anything to publish, then that's not good either. So both type 1 and type 2 are bad. If they're about equal, we use a 5% level significance. Any questions on that? Okay, the next step, by the way, in terms of conducting a hypothesis, is collecting the data. And I didn't collect my own data, but Gallup did. So I'm able to use Gallup's data. And they talk about it. So here's the article on enthusiasm about the elections. And it goes through, and we could read the whole article, but I don't want to waste your time. But in there, it actually talks about Democrat versus Republican in there somewhere. And you'll see that 57% of Democrats are enthusiastic about voting, and 49% of the Republicans are enthusiastic about voting. Any questions on that? And then I'll just let you know, in the article, 497 Democrats, 400 Republicans were surveyed. I did a little bit of just guesswork on that, but good enough. Any questions on that so far? Okay, so now we're ready to go to our calculator. So here's the calculator. Which calculator do you think I'm going to use? What calculator number? I'll let you look. Which calculator is the right calculator for this hypothesis? Okay, 17 turns out to be two independent samples with data. Data would be a bunch of numbers. 18 would be statistics, like the mean and standard deviation. That's also from numbers. 14 is a single mean. That's not what we've got. Yeah, 19. Two proportions, right? We're looking at proportion for Democrats, and we're looking at proportion for Republicans. Any questions on that? So I click that. And what it asks for is the sample sizes for the first and second sample. So I go over there, and that was 497 and 400. So I type those in. I want the number of successes, right? And a success, by the way, just means a yes answer. Doesn't mean a good thing happens. Well, 57% of the Democrats said yes. So it's 57% of 497. So what I'm going to do is I'm going to go to the calculator and I go 0.57 times 497, because that's what we had, 57% of 497. And I'm going to do rounding because this is the number of people who said yes. We're looking at 283. You can't really have decimals. So 283. And then we had 49% of the 400 Republicans. So similarly, we go to the calculator. So 49%. So 0.49. And again, there were 400 Republicans. So 400. Oops, got an extra point there. There we go. And you get 196. Okay, then we have less than, greater than, or not equal to. Well, in our hypothesis, our alternative hypothesis, we have a not equal to. So we're going to go not equal to. We're going to eventually do a confidence level, confidence interval. So how about 0.95, 95%? This is news. And I just hit calculate. Any questions on using the calculator? Um, 0.95 for confidence level, because that's standard, and this is about this is news, politics. Politics just about always uses 95% for a confidence level. Yeah, that's pretty standard. All right. Z is a test statistic. That's like a Z-score. And notice it's 2.37. That's actually really big. And the p-value, we shouldn't be surprised with a big Z, is about 0.018 or so. So let's write that out. Any questions? All right, we're using a 5% level of significance. And the p-value is 0.018. What does that tell us? What do we do from, what can we say or conclude? If the p-value is 0.018 with a 5% level of significance. Right, p is less than the level of significance, and if the p is less than the level of significance, then we do what? Same as last week. Any ideas? Remember, if the p-value is less than the level of significance, that means that you reject the null hypothesis and you accept the alternative hypothesis. And in words, we say there is statistically significant evidence. Remember last week we talked about this? To conclude that, and then you basically rewrite H1 in words. P sub D is the population proportion of Democrats. P sub R is the population proportion of Republicans. Not equal means there's a difference. So there is a difference between the population proportion of Democrats who are enthusiastic about the election and the population proportion, and I'm just going to copy and paste. And the population proportion of Republicans who are enthusiastic about the election. So yes, there's a difference. Democrats are not the same as Republicans in terms of their population proportion of being enthused about the election. Any questions at all? Any questions at all on this? If I lost you, please stop me and tell me. Any questions? Okay, so the next question is interpret the p-value. So just like last week, we start out by restating the null hypothesis with an if. If the population proportion, and I can just, if the population proportion of Democrats who are enthusiastic about the election is the same as the population proportion of Republicans who are enthusiastic about the election, and if we surveyed another, and what do we have? We had 497 Democrats and 400 Republicans. I'll even pop that in. Then there would be a, and the p-value was 0.18 or 1.8% chance that, and now we look at the percentages and notice the Democrats and the Republicans differed by 8%. 57 minus 49 is 8. Any questions on that idea? And remember that the p-value is that probability that if the null hypothesis is true, that you get something as extreme or more extreme as what we got in this survey, which was 8% difference. So there'd be a 1.8% chance that the enthusiasm of Democrats, of these Democrats and Republicans differed by at least 8%. So I'm going to stop here. Let me ask you, are there any questions about the interpretation of the p-value? Any questions? Okay, if there's no questions, let's interpret the level of significance. Just like last week, it starts out exactly the same up to the percent chance. So I'm going to copy and paste. If the population proportion of Democrats who are enthusiastic about the election is the same as the population proportion of Republicans who are enthusiastic about the election, and if we surveyed another 497 Democrats and 400 Republicans, then there would be well, now our level of significance is a 5% chance that the new study would falsely lead us to conclude that, and the idea is that there is a difference between the population proportion of Republicans enthusiastic about the election let me just write enthusiasm for all Democrats and Republicans. About the election. There's a lot of writing. But is there any questions about this writing? And it's very important that instead of just saying, yes, I watched you, make sure you can do it yourself. Because you're going to be asked to do it on the discussion post. And you're also going to be asked to do it on the exam. So it's important that you can do it yourself. And it won't be this example, but something like it. Any questions at all? Okay, if there's no questions, but I'm always happy to answer questions. If there's no questions, we can look at the confidence interval. The confidence interval was, again, the lower bound is about 0.01 and the upper bound is about 0.15. Any questions on the confidence interval, at least getting it? How did I get it? I used the calculator with that 0.95. And I looked at the lower bound. That was the 0.01. And I looked at the upper bound. And that was rounded to 2 decimal places, 0.15. So it's given in the calculator. Any questions on that? Okay. Yes, it's not hard to get it to calculate, but you have to know how to read it. And LB means lower bound, UB means upper bound. Okay, so now we interpret the confidence interval. What's the first word when you're interpreting a confidence interval? See if you remember. I know it's been a few weeks. What's the first word for the interpretation of the confidence interval? Do you remember? Because that gets you started. It's important to know how to get started. So it's a simple word. It's not some fancy math word or anything. I don't see y'all typing it in. All right, then I'll write it with. Remember that? It's been 2 weeks, but it's important you don't forget everything. 95% confidence. The population, or maybe the percent is probably even better in this one, of all Democrats who are enthusiastic about the election is between 1% and 15% more than the percent of all Republicans who are enthusiastic about the election. Any questions about the interpretation of the confidence interval? Do you remember, doesn't this sound real similar to what we did a couple weeks ago? The only difference now is that we have two different groups and you're saying how much more one group is than another group instead of what is one group's range. Any questions at all on this example? Make sense? Okay. I'm going to move on then to another example. Now they're going to be different. So here's the question. Do single women spend more time cooking than single men? What do you think? Okay. I don't see y'all jumping in. Do single women spend more time cooking than single men? Okay. So we got one person saying yes. Okay. I want to let you know, I'm going to give you a heads up. Unlike the last example, I made up these numbers. So this is not a, very, anything you can trust in terms of the data. But you could imagine doing a study yourself, hopefully. Okay. In fact, this would work for your project if you wanted to, but the 35 single women who were surveyed averaged 58 minutes a day cooking, and their standard deviation was 12 minutes. The 38 single men who were surveyed averaged 46 minutes a day cooking, and their standard deviation was 46 minutes. What can be concluded at the 5% level of significance? Also interpret the 95% confidence interval. Any questions on the question? Okay, so on the last example, if you remember, we had our P sub D equals P sub R. How is this one going to be very different? This is very different. It's not P sub D equals P sub R. And it helps to think about what was a survey question. So what's the big difference on this one? The hint is a survey question would be, how many minutes a day do you spend cooking? It's not the men and women. That's different than Republicans and Democrats, but not that much different. Yeah, so it's not P sub M equal and P sub W, because the survey question is how many minutes a day do you spend cooking? Maybe you could put the chat box, how many minutes a day? And by the way, this is not public. How many minutes a day do you spend cooking? And by the way, I don't know if you're single or not, but that's okay. You can still put it in the chat box. How many minutes a day do you spend cooking? Okay, so an hour and a half, or that'd be 90 minutes. Okay, so notice the answer is not yes. Yeah, 60 minutes, 70 minutes, they're numbers. When you have numbers, it's not going to be P sub M. What's it going to be? And this is very important. The hint is P is not even part of it. Remember? Hadn't been that long. Yeah, this one's mu. So it's going to be mu, not P. So it's going to be mu sub W. And we want to see, is our women spend more? So greater than mu sub M. Oh, sorry, greater than it'll be H1. That's equal. And then for the H1 will be greater than. Any questions on this? Why it's a mu and not a P? And maybe why it's greater than instead of not equal to like the last one. There's that keyword more. That's the greater than. Any questions at all on this hypothesis? Okay, I want to note something. These are just a bunch of women and a bunch of men. Do you think the first woman has anything to do with the first man? Or are they just separate people that aren't attached to each other or anything like that? What do you think, based on this study? Yeah, they're not attached. These are independent. So notice these are independent. And that's very important to note. Are we dealing with independent or are we dealing with dependent? And these are independent. On the other hand, had the hypothesis been, do wives spend more time cooking than their husbands? That would be dependent. Because now the first woman is attached or, is with that first man and not with that second man. Do you see that? So, but this one's not. This is independent. Any questions so far? All right, so now we need to go to the calculator. So let's go back to the calculator. And what calculator number do you think we need now? What calculator number? Yep, this one's 18. It's 2 independent samples, and we're given statistics, not data. We're not given the answers to these 35 women. We're given the average for the 35 women, and we're given their standard deviation. We're not given each of the 35 answers. So that means we're going to go to number 18, 2 independent samples with statistics. It's going to ask for the sample sizes, first and second sample. And those were 35 single women and 38 single men. So 35 and 38. Stop me if you have any questions. The sample means for the first and second sample. Well, the average for the men was 58. And the average for the women, the average for the women was 58, and the average for the men was 46. So 58 and 46. And then the sample standard deviations. The average for the standard deviation for the women was 12, and the standard deviation for the men was 16. Any questions so far? Okay, we want less than, greater than, or not equal to. So we go back, and H1 had a greater than. So we go greater than. Confidence level, we want a 95% confidence level. So 0.95. Any questions on the input of everything into the calculator? Okay, then hit calculate. And there we have it. Notice it's a T. Remember, this is quantitative data. We don't know the population standard deviation, so that T does that little adjustment based on the fact that there's an extra error by using the sample standard deviation to approximate the population standard deviation. That's why the T and not the Z. The p-value, 0.00026. Very small. Any questions so far? Okay, so the next thing is we should make our conclusion. What's the conclusion? If P is 0.00026. Conclusion is less. Yeah, P, so I mean, you really meant P is less. Yeah, P is less than the level of significance. I think that's what you meant. Yeah, so P is less than the level of significance. If P is less than the level of significance, we reject the null hypothesis. So that means there is statistically significant evidence to conclude that, and now we kind of restate H1, but not in symbols, but in words. Mu is population mean. The population mean. And then what it was about was number of minutes per day women spend cooking. Is greater than the population mean. Minutes per day, or number of minutes per day men spend cooking. Any questions? Any questions on this example? Okay, by the way, what if the p-value had been, instead of 0.00026? And by the way, when the p-value is really small, usually less than 1%, sometimes we'll say strong. Statistically significant evidence. Okay, that's for very small p-values, like less than 0.01. Then we'll say strong. If the p-value is, say, 0.04, then you wouldn't use the word strong. Okay, what if the p-value is 0.06? How would that change things? What does it mean for the p-value to be less than the level of significance? So the p-value is if the null hypothesis is true. So if men and women are the same in terms of, cooking hours or cooking minutes, and we did another study, it's how rare it would be to get women to have the sample mean for women be so much bigger than the sample mean for men, or even bigger than that. So the idea is that that p-value is very small, smaller than 5%, because that's our kind of line that we're cutting. Then we're going to say that this assumption that mu sub w equals mu sub m is wrong, and that mu sub w is greater than mu sub m is right. Because if it's really, really small chance, you're going to say something's wrong. If I flipped a coin 200 times and got 199 heads, what would you say? What would you say if I flipped a coin? You'd say it's rare? Okay. I would, if you did it, I'd say you're cheating. Does that make sense? This is not going to happen. Do you see? And I'm going to say you're cheating. It's not a 50-50 chance because you're cheating. Do you see how that works? Yeah, so that's what it is. If that probability is so small, rare means small p-value. P-value is rarity of what happened. And if it's so rare of that or even worse happening, then you're going to say something's wrong. There's a cheating going on. H0 is not right. H1 is right. Do you see? And that's how this works. So good questions you're asking. Really good. Really important. Okay. I just want to let you know this one I made up. So don't, talk to your friends and say, hey, I learned in class that women spend more time cooking than men. I just made up these numbers. But could a study like this be done? Yeah, wouldn't be that hard. You just do a survey and you'd ask, okay, or an observation, one or the other. Okay, so now let me give you something real. Okay, this is something, it was years ago, but I think it's always fun to see where I could do something really well and literally make thousands and thousands of dollars because I noticed something statistically. And if you could do that, you can make thousands and thousands of dollars. And this is something I did. This is personal, but it's something I figured out. Okay. And no one in the country figured this out. And I even gave a name for it called playing the tweet. Okay. Now, if you remember, we had a president that used to tweet all the time on Twitter. Who was that? What president of the United States tweeted on Twitter all the time? Yeah, that was Trump. Okay. And by the way, in my class, I never tell you who you're supposed to like and not like. Okay. But I will tell you something that I did like, and that is I made thousands of dollars because I figured something out. Okay. Not because I like Trump or anything, but I figured something out. Okay. And what he used to do is he would tweet about China. Okay. I don't know. Those of you who remember, it definitely happened. I'm not making things up. And what I noticed is that when he tweeted about China doing something bad, the stock market went down. Okay. I don't know if any of you all noticed that too, but I noticed it. And that's something I look at. And then within about a week later, the stock market would come back up to what it was before the tweet. And I was just noticing that. So then I went and I tried to find the stock that seemed to react to it more than any other stock, and a stock that I would trust. Does that make sense? So what I did is I collected some data on the NVIDIA. Have you heard of the company NVIDIA? NVDA is the stock market letters, NVIDIA. Those of you who are gamers might know. It's a big it's a big company that does computer chips, and especially for gaming and some other things too. And what I noticed is that they tend to react to Trump's tweet a lot. And what I did is I collected the data for NVIDIA's stock price on what I call tweet day. Okay, so right after Trump tweeted, and then a week after Trump tweeted. and I collected the data. Any questions on this? Okay. By the way, do I need to make any assumptions to do any kind of hypothesis test here? Looking at my data? Do I need to make an assumption or any assumptions to be able to do a hypothesis test? Okay, the answer is yes, because the sample size is 6. There are only six pairs of data that we've got. And the sample size is 6, which is much less than 31. So I have to assume the distribution is normal. Okay, which I did. It's probably not perfect, but it wasn't so bad. Okay, so what I'm going to do is I'm going to look at this. Are these independent of each other? If you look at, say, the 106 and the 113, 110 and 124, are they independent or are they dependent? Any thoughts? One more guess. Yeah, these are dependent because what it is it's tweet day versus a 1 week later. So this 106, 113, these are paired, right? So it's, whereas say 106 and 124, those have nothing to do with each other. So this is the day and then a week later of that day. And that makes them dependent because it's that day's 1 week later. Does that make sense? So these are dependent data, and that's important. When you have dependent data, everything is different. And what we're going to do is we're going to say, instead of is the mean for tweet day the same as the mean for 1 week later and look at it as independent data, what we're going to look at is say, is the difference between tweet day's value and 1 week later's value. You look at the mean of the differences and say, is the mean of the differences, is that equal to 0? So first thing, it's a mean. These are numbers, so I'm going to have mu, and we're going to have sub d for difference equals 0. So notice in this one, there's just one mean. It's mean difference. Any questions on that idea? Because you could say the first difference is 113 minus 106, which is 7. Second difference is 124 minus 110, which is 12. 14. The third is 120 minus 115, that's 5. The fourth would be 118 minus 122, that's -4. So it's a bunch of differences, and we're saying is the mean difference 0. Okay, now I want to make money. So because I want to make money, I'm going to say mu sub d. And what am I going to do? So if I'm looking at the differences, what do I do? If I want to make money, I want to say, is 1 week later higher than tweet day, or the difference should be positive. So now what I'm going to do is I'm going to go back to the calculator. Let's go to our wonderful calculator. And which calculator do I use? Okay, they're not independent. Yeah, it's 20 because they're two dependent samples with data. So I can go to 20. And here we just type in the values separated by commas. I think it'll allow me to go like that, copy and paste and throw in some commas. So I don't have to look back and forth. Yep. Comma, 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 comma. And data 2. That's these guys. Paste. Comma, 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 comma. Okay. Any questions so far? Confidence level, 0.95. How about? Actually, this one I probably don't need it that much. I have a small sample size. I don't need to be 95% confident I'm going to make money. I'm going to say 90%. Sorry, I actually want less than in this case. Sorry about that. It's the first minus the second is the way things work. Uh-oh, something happened. So sorry about that. It's a less than because it's first minus second. So 9 or 90. It's 0.9. You could write 0.90. It's the same thing. Does that make sense? 0.9 and 0.90 are equivalent as decimals. So whichever one you like. They both give you the same thing. There we go. That's better. Okay, our p-value is about 0.02. What does that tell you? What does that say? If the p-value is 0.02, yeah, p is less than, so there is statistically significant evidence to conclude that the population mean stock value before or on the day of the tweet is less than the population mean stock value on 1 week after the tweet. Okay, notice a confidence interval is negative 1342 to negative 224. Okay, so not only do we know that the stock value is lower on the day of the tweet, but now we have an idea of how much lower. So we can say that and again, we're using, in this case, 90% confidence. The population mean stock value on the day of the tweet is between $13.42. And actually, let's go the first one, 224. $2.24 and $13.42 lower than the population mean stock value 1 week later. Okay. And by the way, given that, it's a little over $100 a share, that's like somewhere between, a couple, 2% and like 10% or so. Okay. So what do you think I did? Any thoughts? Any guesses what I did? And this is real. It's important, how do you use these things? So as soon as I did this analysis, what do you think I did? I don't see y'all jumping in. So I'll tell you. I waited till he tweeted next, and then I put thousands of dollars into NVIDIA stock, waited a week later and sold it, and then did it over and over and over again, like 6 times, every time he tweeted, which was pretty many times. Of course, it doesn't last forever because no one's president forever. And do you think I made money? Yeah. Okay, I made a lot. Okay, very, very high percent in terms of, for the year. So it was a big money making. And if you can ever find something like this in the stock market, use it and then make a lot of money. So that's what I do. Any questions on this strategy? Okay, it's not always easy to find these things, but when you can, it's good. Biden unfortunately doesn't tweet. And it's really hard I haven't been able to figure out how to make money out of Biden. Maybe I'll get there, but so far I haven't found any big things like that one. Any questions on this idea? Okay, so notice this was a hypothesis test for dependent data. Very different than the independent data one. Okay. So I had this instead of been, tweet day versus 1 week later, had it been something like you just looked at, I don't know, 6 men and 6 women, and you put in the data, they're just random men and women, then it would be dependent. So you got to understand the difference. Is that, are they paired? Do they have any, are they paired up? Or are they not paired up? So typical dependent is this kind of thing where it's timed. So before and after kind of study, and that's what this is. This is a before and after study, before tweet, after study, or day of tweet, and then after that day. And then often you'll get, if you ask someone 2 survey questions, like something like, how many calories do you eat for breakfast and how many calories do you eat for lunch? And you compare them, that would be dependent also, because you're asking each person 2 questions, and that's paired up, right? Or dependent. Whereas if there's 2 different populations and there's no ordering of them or anything, then that would be independent. And it's always for the quantitative survey question. So it has to be the data has to be a bunch of numbers, not yeses and nos. Any questions on these? Okay, I want to let you know the secret word is order. Because if the order matters when you're doing, if the first versus the first, second versus the second, then it would be dependent data. Whereas if the order that you put the numbers in doesn't matter at all, then it's independent. So the secret word is order. Very important to be able to handle that. Okay, so the last thing I want to do today is talk more about the project. We talked about the project last time. But now we actually have everything we need to understand the project. So let's go back to, where'd it go? Just a second. I think it got canceled, so let me do this. So if we go back to the syllabus, and we go to projects. So here, if you click on project 2, then this gives you the ideas of project 2. And again, I've talked about it already, but now we understand hypothesis test for difference. So you're going to use a confidence interval in hypothesis testing. That's what this is all about. And you're going to support or show lack of support for some kind of idea you have. Okay. You also, just like project 1, you have to identify a client. If nobody would be interested in what you're doing, then it's not a good project. So it has to be something somebody would care about. Okay. So that's what you're to do. Okay. What should you have already done on this project for this project? Remember? It's something I told you last week. Yeah, partners. So hopefully you all have your partners. That's important. If not, you need to get partners. Okay. 3 is best. 2 is okay. 3 is better. And, you know, if you worked with people last time, make sure they're still around. Make sure you're still happy working with them and work with those partners. You don't have to work with the same partners, but you do need to have partners. Okay, so you get partners. The next step is to write out your hypothesis. Your hypothesis is either going to be like a mu m equals mu w or a mu whatever you're looking at versus mu the other thing, or it's going to be a mu sub d equals 0 for the null hypothesis. So what I want you to do is I want you to post in the project 2 discussion board what your null hypothesis is and what your alternative hypothesis is. Is that clear? And in symbols and in words, but if you want to use words for the symbols, that's okay. If you want to write mu, that's okay. But describe what you're doing, talk about how you're going to collect your data. You're allowed to do convenience sampling, no problem. But you just have to, if you can't collect the data, then what's the point? Don't even think about the project. Does that make sense? So if you want to do a, you know, to see, I don't know, how much weight, what's the, do you think there's a difference in the amount of weight that men and women lose when they go to the moon? What's the problem with that? You could definitely do a, you know, mu sub W is maybe less than mu sub M for weight loss. But what's the problem with that project? Why can't you do that project? That would not be a doable project. Yeah, exactly. Not enough men. People have gone to the moon, and especially women, by the way. You know how many women have been on the moon? I know you weren't born, but and I was just like a baby. Yeah, so the answer is 0. We haven't had any women on the moon yet. So, and you're not going to be able to get women to go on the moon in the next, you know, couple weeks, or men, by the way. So not a chance. Okay, so make sure that it's data that you're actually going to be able to collect. If you can collect all of the data, then it doesn't work because you don't need to do a hypothesis test if you can get everything. So in other words, if you can get the whole population without much work, then it's not a good thing. Any questions on that? Okay, so that's really important. So we're going to go through the step-by-step that we did last week. First thing is come up with your idea. Second is to write down your hypothesis, null and alternative hypothesis. It'll either be a mu1 equals mu2 or a mu d equals 0 kind of thing. Then think about how you're going to collect your data, then post it on your project 2 discussion board. Got it? So post on the project 2 discussion board. I'll let you know if it can work or not. Don't wait until the last minute to do that. I recommend doing that within a week or so. Okay, maybe with, so maybe by Saturday or something, and have an idea, and I'll help you out to tell you, yeah, that's going to work, or no, good luck. You're not going to be able to, find women and men who've gone to the moon, not over 30 of them. So it depends on what your idea is, or I'll say, no, that's a yes, no question, and you can't do yes, nos. You do not need to do a survey. What do I mean by that? Yeah, you doesn't have to be asking people. Could be collecting data. There's a lot of data that can be collected. Okay. So, kind of things like, is it maybe, how about colder in Minnesota or New York? And you can collect data by going to the Weather Channel and finding out a bunch of days on New York and Minnesota, and look at what the days were and look what the weather was. Does that make sense? And you didn't ask any people anything. All you did is go online. But you're not going to be able to get the weather for every single day that's ever happened in New York and Minnesota. That's why a sample makes some sense. Any questions on that? Okay, so that's important. Post it, and I'll help you out. I'm here to help. Okay, so once you have done that posting, and once you have your idea, and once I say, yeah, that's going to work, what's the next step? Remember the next step in hypothesis testing we went through last week, step-by-step process. After getting your null and alternative hypotheses. Actually, before you start collecting the data. There's a step that comes before. You remember? You reflect on the type 1 and type 2 errors. And then based on that, you decide what the level of significance should be. And that should happen before you collect your data. Does that make sense? Remember doing that last week? And remember, your level of significance is going to be either 1%, 5%, or 10%, depending on which is worse, type 1 or type 2 error. And if they're the same, it's 5%. So that's their next step. Then the next step, as you said, is you collect your data. And that collect data, you're allowed to do a survey, but you're also allowed to, grab stuff online or whatever, and, find data, as long as it's data as long as you can't find the whole population, there should be like at least 10 times more that you can't find than what you did find, kind of thing. Then you get your data. And what are you going to do with your data at that point, once you have a bunch of numbers written on a piece of paper? Or a bunch of pairs of numbers? What's the next step after you have your data? You remember? You all know the step. It's not that hard a step either. All right, don't see y'all jumping in. You put it into the computer spreadsheet program. So let me remind you, This is the spreadsheet program. Do you remember this from project 1? Okay, hopefully you do. So if you did project 1 and you grabbed it and then you saved it under your own name, then you don't have to do it again. You already have it. Just reopen it. But for project 2, we're not doing 1 Veristats. We're doing 2 Veristats. Okay, we're looking at a difference between 2 means. So you're going to click on the 2 Veristats tab. Any questions on that so far? Okay, then what you're going to do is you're going to take your mouse, you're going to highlight the data that's in there. You can hit the backspace to erase it. Any questions on that? And then you're going to put in your data. So let's say your data was 34, 12, 18, 19, 23, 42, 55. Okay, and I'm not going to waste your time, but you got to have at least, you have to have over 30 for each of these. And the second, let's say, was 51, 67, 23, 20, 69, 50, 30. Okay, and again, you're gonna have a lot more than this, but I don't want to waste your time. So I just put in the data. Is that clear? I tried to make it easy. So what you need to be able to do at this point is know how to move your eyeballs. So let me show you what it gives. It gives stats for A and stats for B. So that's stats for the first column, stats for the second column. And then the next are really important. And that is difference independent, and then stats for dependent difference. Do you see that? And it also gives the differences. These are the subtracted numbers. So depending on whether you have independent or dependent data is where your eyeballs need to go. Okay, the computer doesn't know how to read your mind. It doesn't know if it's dependent or independent. It's going to put them both up there, and you have to read the column that relates to your particular study. Any questions on that? Okay, and then it's going to give you everything you need. So the standard error, for example, is 9.5, 9.6, let's call it that. And you need to fully interpret the standard error. And there's a lot to do on the standard error. One is just by itself, what would this 9.6 tell you? And what decisions might the client make after seeing it? Another would be, is the standard error small enough? And that's based on the confidence interval, whether you're happy with the width of the confidence interval, the margin of error. And if you're happy with the width, if it gives you good information based on these numbers, then the standard error is good, and you wouldn't need to increase your sample size. On the other hand, if you're not happy with these, then standard error is not good enough and need to increase your sample size. Any questions on that so far? Okay, you put in your level of confidence. Okay, and unlike the level of significance, the level of confidence you could determine after you've collected your data and look at it and say, well, 95% gives you this confidence interval, whereas a 99 would give you this confidence interval, whereas a 90 would give you this confidence interval. So which works for your client? There's kind of three, you use all three of them, look at the three choices, talk about it in your paper, and then talk about the pros and cons, and based on the pros and cons, what will your client do? Any questions on that? Any questions? Okay. The way I set this up is it gives you p-value two-tailed, right-tailed, and left-tailed. So you have to decide which is your particular hypothesis. Your H1 has to do with your H1. and read the right number, the correct number. And by the way, you might be over here with independent, and the same stuff is there with independent. Any questions about all this stuff? And just note, just like project one, for every important piece, you need to talk about what decisions the client will make. Okay, that's really important after seeing that particular piece. So lower bound, what decision will the client make? Upper bound, what the decision will the client make? They're going to be different. Any questions at all about this project? Okay, just to note, just like project one, if you send me your draft, then I'll take a look at it and let you know changes that need to be made. And again, you definitely want to, before you do that, make sure you've posted your idea for your project so I let you know if it's going to work. Because if it's not going to work, you send me the draft and I say that's not going to work. And then all you can do is start over again, and that's the end of looking at drafts. So that's just a note. Any questions at all about this project? Here. Okay. And I'm going to let you read through all of this stuff. Also, standard error, if you forgot, there's a video on it. I think I mentioned it last week. I'll let you look at it, and I'll let you look at all this stuff. Any questions at all on project 2? Any questions? Okay. If there's no questions, I think we're going to call it a webinar. I'm going to stop the recording.